The connection that killed 114 people had never been checked against the load it would actually carry. Not because anyone forgot. Not because the paperwork was lost. Because no one in the approval chain realized the design had been changed. On the evening of July 17, 1981, two suspended walkways inside the Kansas City Hyatt Regency Hotel held approximately 160 people. They were watching a dance contest in the atrium below. At 7:05 p.m., a single threaded rod nut began to pull through a steel box beam. The math had never been done. It showed. This is Fail Point, tonight's report, the Hyatt Regency Walkway collapse. Kansas City, 1976. The Hyatt Corporation breaks ground on a 40-story hotel with an ambitious centerpiece, a soaring atrium lobby, 4 stories tall, crossed by 3 suspended skywalks. The walkways were designed to hang from the ceiling, literally, using long steel rods threaded through box beams, the beams carrying the weight of the walkway deck. It was an elegant solution, architecturally. The engineering firm responsible was Gillum Calaco Incorporated. The project's engineer of record was Jack Gillum. Construction was contracted to Haven Steel Company. The original design was straightforward. 2 continuous rods would run from the ceiling all the way down, passing through both the 4th-floor walkway and the 2nd-floor walkway below it. Each walkway beam would be held by a nut on each rod. The rod carried tension. The nut transferred load to the beam. Simple. Under that design, each nut on the 2nd-floor connection bore only the weight of the 2nd floor. The 4th floor carried its own load higher up. 2 separate load paths, 2 separate connections. The system was never spectacular engineering, but it was coherent. That coherence would not survive construction. The Hyatt Regency opened in July 1980. The atrium was considered one of the most striking interior spaces in Kansas City. The walkways became a feature, places to stand, to look down, to be seen. On busy nights, they filled with guests. What those guests stood on was a welded steel box beam, 2 channel sections welded toe-to-toe, forming a hollow rectangular tube. The hanger rods passed through holes in those beams. A nut and washer underneath each beam held everything up. It is worth understanding what that means structurally. The beam was not gripping the rod. The rod's nut was gripping the beam. That distinction matters. During construction, a problem emerged. Threading a continuous rod 60 feet long is difficult. Aligning it through 2 walkways and securing it is harder still. Haven Steel, the fabricator, proposed a change. Instead of 1 long rod running through both floors, use 2 separate rods, one from the ceiling to the 4th floor beam, and a second rod from the 4th floor beam down to the 2nd floor. On the surface, it sounds equivalent. It is not. Under the original design, the 4th floor nut carried only 4th floor load. Under the new design, that same nut now had to carry the 4th floor walkway and support the entire 2nd floor walkway hanging below it. The load on that connection had doubled. The change was communicated by phone. A sketch followed. Gillum Calaco approved it. No load calculation was performed for the new connection geometry. The engineers later stated they believed the change was a fabrication convenience, not a structural alteration requiring fresh analysis. But the physics did not care about intent. Think of it this way. Imagine hanging 2 buckets from a coat hook. In the original design, each bucket hangs on its own hook. In the revised design, the lower bucket hangs from the upper bucket's handle, and that handle, the nut against the beam flange, must now carry both. The hook had a rated capacity. No one had checked whether the handle did. The Kansas City Building Code required connections to support twice the expected live load, a standard safety factor of 2. The original rod and nut connection, even before the change order, was later calculated to have met only 60% of that requirement. After the change, the 4th floor connection was carrying load that exceeded the code minimum by a factor of nearly 2, in the wrong direction. The built structure, as modified and approved, could not legally have been constructed had anyone run the numbers. The approval stamp on the revised drawing represented a check that did not happen. The walkways opened anyway. They held until they did not. Between the opening in 1980 and July 1981, there were warnings, though none specific enough to trigger action. A hotel maintenance worker noticed cracking sounds from the walkway connections on busy nights. An atrium balcony had partially collapsed during construction in 1979, an event attributed to temporary support failures. Neither incident produced a formal structural review of the hangar connections. The walkways were inspected visually. Visual inspection cannot reveal that a nut is bearing twice the load it was designed for. The failure mode was internal, slow, a matter of stress concentrations building in steel that looked, from any angle anyone checked, completely normal. July 17, 1981. A tea dance. Approximately 1,600 people in the atrium. The fourth and second floor walkways held roughly 160 guests between them. At 7:05 p.m., the fourth floor walkway's north connection let go. The box beam's upper flange tore around the rod. The walkway did not fall cleanly. It rotated, pulling the second floor walkway with it as they were still linked by the lower rod. Both spans, together weighing approximately 65 tons, fell onto the crowd below in under 2 seconds. 114 people died. More than 200 were injured. It remains the deadliest structural failure in United States history that was not caused by a natural disaster. The investigation was led by the National Bureau of Standards, now NIST. Their 1982 report was unambiguous. The cause was the change from a continuous rod to a 2-rod system, which doubled the load on the fourth floor connection. That connection had never been calculated for the load it actually carried. The Missouri Board of Architects, Professional Engineers, and Land Surveyors found that Gillum Colaco had committed gross negligence. Jack Gillum and Daniel Duncan, the project engineer, had their licenses revoked. Haven Steel had proposed the change, but the engineer of record held the legal responsibility to verify it. The stamp meant something. It had to. 114 people. The youngest was 5 years old. The oldest was 83. They came for a dance competition on a Friday evening. The failure that reached them had been locked into the structure 14 months before the hotel opened. On the day an approval was given for a design change whose consequences were never calculated. Engineering codes across the United States were revised after 1981 to require that any design change affecting load pads receive full independent structural review. Shop drawing approval procedures were tightened. The profession acknowledged, formally and in writing, that a stamp without a calculation is not an approval. It is a signature on a blank check. The Hyatt Regency Walkway did not fail because steel is unpredictable. It did not fail because the loads were unusual or the building was old. It failed because a phone call changed a design. The change doubled a critical load, and the person whose job it was to catch that never ran the numbers. The structure stood for 14 months looking exactly like a safe building. It was not. The calculation that was never performed was always there, waiting. Every engineer who has read this case report knows what it costs to skip a step. The number is not abstract. It is 114. Every failure has a point. Find it before it finds you.